Hi, everyone. Welcome to our talk. We're going to talk about Alloy's OpenTelemetry engine. We're going to talk about what's new and what's next. My name is Marko. I'm a software engineer here at Grafana Labs working on the fleet management team.
And I'm Bejal. I'm a software engineer working on the Alloy team.
Yeah, and we're super excited to present to you all of the OpenTelemetry capabilities we've been working on for the past year. But before we talk about what's new, let's actually take a look back to how we got here. 2 years ago, at GrafanaCON, we announced Alloy as a collector that supports both Prometheus and OpenTelemetry protocol formats. Last year, we did a deep dive into Alloy, where we proved this integrated approach by unifying a high-performing Prometheus pipeline with OTel collector workflows in Alloy. Now, this year, we continue to pave the way forward by making Alloy an official and fully compliant OTel collector distribution with native YAML support. Why? You might be wondering why. And there's a few reasons for that. Reason number one is that the upstream community actually tightened what it means to be an OTel collector distribution. And so in the spirit of being community first and adopting open standards, we really wanted to put out a product out there that will fit that definition entirely. The second reason is that more and more customers are demanding a vendor-agnostic workflow. Ideally, they would like to use a config language that's transferable across vendors. And last but not least, we took a look at not only the current state of the OTel collector, but also the future developments. Our goal is that Alloy develops and evolves as the OpenTelemetry collector evolves and sort of gets those changes by default, no developer effort required on our end. So why does this matter to you folks? And it matters a whole ton, because Alloy is Grafana's most widely distributed software out there and most widely deployed. It's one of the most popular OTel collector vendor distributions. OpenTelemetry has now become the industry standard for generating, instrumenting, exporting telemetry data, and Alloy's new engine will give you native access to the broader ecosystem of OpenTelemetry. Now, I've talked about the why. Let's talk about the what. Bejal, can you tell us how this works?
Yes, absolutely. I'm actually going to start with something slightly unorthodox. I'm going to kick off a demo right now. And you'll all see what I'm running in about 5 minutes. But I just want to give that a bit of time to calibrate. And while that's running, just a general vibe check question for the crowd. Could you raise your hand if you've already used the OpenTelemetry Collector before, or if you're familiar? Okay, yeah, lots of hands. Cool. So if you have already used the collector before, I think a lot of the terms that we're using throughout this presentation are going to sound really familiar. But if you haven't raised your hand, no problem. You don't have to be an expert to follow along. So I'm going to actually check back in with my demo right now, because I want to make sure that that is running properly. Just give me 1 second to sort that out. Great. OK, I think that's running. OK, so now back to the slides. I did, just before we get into the juicier details of the OpenTelemetry engine, I want to actually start by defining what we mean by engine. And when we say engine, we're referring to the underlying runtime in Alloy that is wiring together the components that you define in your configuration and allowing telemetry to run through them. And so Alloy, as it stands, ships with the default engine. And if you've used Alloy, this is probably the engine you're most familiar with. It comes with many different components that span across multiple ecosystems. So it works with, or we wrap upstream OpenTelemetry components. We wrap Prometheus components. We have lots of different Loki components as well, and so forth. It's sort of designed to work with many different sources and destinations of telemetry of many different formats. It's really a Swiss Army knife in that way. And the language that the default engine speaks is Alloy configuration syntax, or the .alloy file that you would pass into a running collector. And that syntax was developed in-house, and it was chosen for a reason. It's very rich and descriptive, and it pairs well with the underlying complexity of the default engine, and so they work really quite well together. And what we're introducing now is the OpenTelemetry engine. That's the primary focus of this talk. And the OpenTelemetry engine is essentially the upstream collector runtime embedded entirely within Alloy. And that has some really cool implications, namely that it is automatically compatible with anything OTel. So it, out of the gate, understands OpenTelemetry components, OpenTelemetry YAML configuration syntax, and so forth. And so you get the native experience from within Alloy. And both of these engines live side by side. So last year at GrafanaCON, there was a talk about what an OpenTelemetry collector distribution is and why that's important. And just to hash a key takeaway there, because I think it's also really relevant here. A collector distribution is a collector that is able to ingest and understand OpenTelemetry YAML configuration syntax. So it needs to be able to wire together the receivers and processors and exporters that you define. And that gives you something really important, which is a vendor-agnostic collector experience. So there are many different distributions out there, but they all share the same language. And this is sort of the ethos of OpenTelemetry, is these open standards that can be implemented by different vendors, but used together. And so with the introduction of the OpenTelemetry engine in Alloy now, we officially meet this upstream definition of a collector distribution. And that was really important for us to do because, as Marko was saying before, OTel is becoming a de facto standard for how we want to describe and ingest telemetry. And so you want to be using a collector that sits well in that ecosystem and that also speaks that language. And so Alloy gives you that. So now what's actually included? So it was released a couple of minor versions ago in version 1.14 with experimental stability, and it's still in experimental stability. And the main feature is a new OTel subcommand. It behaves similarly to the run subcommand that exists in Alloy. It allows you to define one or more configuration files or configuration sources. You can validate them, and then you can kick the collector into action. And if you raised your hand before that you've used the OpenTelemetry Collector before, it actually exposes the entire upstream collector CLI experience. So it's going to look really familiar to you. We're also introducing a new Alloy engine extension. This is really interesting. I'm going to demo that in a second. But it allows you to run an instance of the default engine pipeline alongside the OTel engine pipeline. So you can run them both in parallel from a single Alloy instance. And we also made sure to include an embeddable health dashboard as well, because if you're running your collectors in production, you really want to be understanding how they're performing, making sure they're using the correct amount of resources and data is coming in and going out. So it was important for us to include that detail in the experimental release as well. And this is less of a feature and more of an architectural decision that we made. But the OTel engine is based off of OCB, or the OpenTelemetry Collector Builder tool. That's a tool from upstream, and it allows us to define the components that we are going to bundle into our distribution in a declarative manifest file, and it will generate the core collector logic that's run. This is sort of the secret sauce to how we get it to be automatically native, because we're using upstream tooling, and so we automatically get upstream code into Alloy this way. And the second benefit or takeaway here is that the components that we include in Alloy have to adhere to a certain standard. That's how they're able to be used with the OCB tool. And so any new components that we introduce or that we currently have are not just glued to Alloy as a collector. They're also accessible to any other collector distribution as well. And so that's a lot of new features, but it gives you a couple of things. The first is it's backwards compatible. So if you're already using the default engine and that experience really works for you, then it's entirely opt-in. You can use the extension to try out the OpenTelemetry engine in the same workloads, or you can use a different deployment. So there's some room to try it out, but in general, nothing changes. It also gives you a really easy migration path. So if you're already using an upstream OpenTelemetry Collector and you have OTel YAML configuration, you can just point that to the OpenTelemetry engine and you can be off the ground. And the same applies in inverse as well. So if you're using the OTel engine and you want to try out a different distribution, you can also go that way too. And another really interesting benefit is custom builds. So we're using OCB. Alloy is open source. You can check out the Alloy source code and you can edit that manifest yourself, and you can very easily spin up and rebuild Alloy. So you could remove a bunch of components, you can add different components, you could develop your own and introduce them, but it's really easy to get started, and so it allows you to sort of meld Alloy to be the collector that suits your use case if it doesn't already do so out of the box. So a ton of flexibility there. So now we can move on to the demo. Great. Cool, just a bunch of logs. I've kicked up a Docker Compose application now, and I'm running a single instance of Alloy, and I've got the engine extension enabled as well. So we should see both engines running side by side. And I've developed a dashboard in the backend. Oh, seems like we're not getting data through here, but I can actually just explain it as we go. Now we're getting data through. So this is a visualization of the pipelines that I have configured. The OTel engine I've configured with an OTLP receiver, and I'm sending spans and traces from the services I have deployed locally. Those are getting batched, and then they're getting sent to the backend. And I've also included some meta monitoring as well, just so we can check how things are going. And if we scroll down a little bit, we can see some data. And if we scroll down some more, we can see that we have an instance of the default engine pipeline running. And this one I've configured to use Bejal. That's a really interesting feature that we have in the default engine. It allows us to auto-instrument applications that are running on the network. And I've decided to do that here, scraping those targets, and we're writing it to the backend. And the main takeaway that I want from this demo is that you can sort of pick and choose the strengths of either engine to your liking. The choices that I've made here also reflect what we've done internally at Grafana. So a lot of our metrics pipelines for monitoring our infrastructure are based on Prometheus exporters. And so we have Prometheus-native pipelines. And the default engine ships with really, really performant Prometheus components. We have lots of other goodies in there, like remote write v2, so we get tons of network savings. And in general, the default engine is a really strong choice for us. When it comes to distributed tracing, though, we really like the way that OTLP describes spans and traces. It's very rich and structured in metadata, makes very powerful visualizations in the backend. And so that is a really strong choice for us. And even before we introduced the OTel engine, we were using wrapped upstream components in the default engine to instrument our workloads. And so now, why not just cut straight to the source? We can use those components and speak their language directly in the OTel engine. So I think we can go back to the slides. What I just showed now is like a really small scale example. There's just a couple of applications that we're running in a Docker Compose file. But we also have the engine deployed to one of our largest dev clusters as a dog fooding exercise. And I have a slide here that's aggregating some data over a 24-hour period. And you can see that in that time, we're receiving over 12 billion spans to the engine, which is a huge amount. In the second slide down, you can see that the amount of data is, we have a spike of incoming requests at a certain point. We can see that our pod count also responds really well to that. So we're scaling really well to those requests. This is deployed in Kubernetes. And all throughout, we have a stable export rate too. So all that to say, you can run this engine locally. It's really easy to get off the ground. But it also works in large-scale environments that have thousands of services and billions of data points as well. So a couple of things that make Alloy stand out as a distribution. First, Alloy has been around for a couple of years now, and it's gotten a very positive response from the community. To try and find a way to put that into a number, we have around 8 million Docker image pulls as of last week. So it's very well used and battle tested. And with those millions of pulls also comes millions of different environments that Alloy runs in. And it works in those environments, so it's incredibly versatile. And so now when you introduce the OpenTelemetry engine into the picture, you also get the standardization and portability of upstream, alongside the huge amount of flexibility and the Swiss Army knife that is the default engine. And you get that all in a single collector. So as I said, the engine is currently in experimental status. We're slowly budging it towards general availability. And as we do that, we are focusing on identifying the strengths that we have in the default engine and finding ways to contribute those upstream, either via new OCBable components or contributing to existing components. And likewise, when it comes to introducing new features to the OTel engine itself, we want to make sure that it's done in a way that is OCBable and is accessible to other collectors as well, and not just tied to Alloy. And something that we're actively working on right now that we're really excited about is enabling remote management of the OTel engine at scale.
So when we talk about scale, what we really mean is running tens, hundreds, for some of you even thousands of telemetry collectors at a time, and managing those instances, making sure they're alive and healthy, and pushing out new configuration changes can become a real pain. So much so that you would probably need a dedicated solution just for collector management. Now, let's say you were to try and create such a solution. There are a few capabilities that you will want to see. Number one is that you should be able to standardize your configuration. So you create that once and then send it out to any number of collectors. Number two is that you should be able to control the rollout of that configuration. You don't want to have to define 5 configuration snippets and then every single one of those gets sent out to every single collector. Instead, you can be smart about it and maybe choose something like matching by collector attributes or a different method to, to really control the rollout of your configuration. And finally, you should be able to change your configuration dynamically on the fly, whether that is by changing some values inside the config itself, adding or dropping a component from your pipeline, or maybe even turning on or off an entire data collection pipeline. You should be able to do that at the click of a button. Now, fortunately for you, we at Grafana have felt that pain. So what if I were to tell you that we have a solution that already does this and then more? Who here has heard of fleet management? Nice, I see a couple hands. Okay, so fleet management is our collector management solution for Alloy. What it does is it provides this centralized control plane where all of your Alloy collectors register, and you can check out their health, roll out new configuration changes, all from the same place. Now, to give some numbers at you for its success, we have over 7,000 organizations actively using it, over 100,000 custom configuration pipelines enabled currently, and over 360,000 active collectors receiving configuration from our servers at this very moment. Now, naturally, given how popular fleet management is, we wanted to extend that experience to other OpenTelemetry collectors as well, not just Alloy. And so, to that end, we've implemented an OpAMP server in fleet management. For those of you unfamiliar, OpAMP stands for the Open Agent Management Protocol, and it's the OpenTelemetry standard for remote management of agents. Now, our solution is currently in private preview, but it's on its way to general availability, and you will be able to try it out shortly. Once it's out, you'll be able to use Grafana Fleet Management with any OpenTelemetry collector. And the best part of all is it's completely free to use, no charge to you whatsoever. Let me show you how it works. Okay, we can go back to my laptop. So this is the fleet management UI. As part of the demo, I've connected 2 collectors, and I have a local service running that's creating logs. Now, what I would like to do ideally is I would actually like to create a configuration to pick up those logs and send them to Grafana Cloud. Now, I have my collectors here. I can click on one, and I can see its health metrics in the dashboard at a glance. I can check out the collector's own logs, and I can also view the collector's attributes. This is particularly important because these attributes are what you use to match different types of configuration to this particular collector. Now, let's actually pick up the logs from my locally running service. I'm going to go on my remote configuration tab, and I'm going to create a new config pipeline. I can choose the OpenTelemetry config language, and there are some integrations built out of the box for common use cases, but let's just go with a custom one for now. It's easier. I'm going to give my pipeline a name, and I am going to drop this configuration in there. Now, at a high level, what this does is I'm configuring an OTLP receiver to just pick up telemetry at these two ports. I'm going to send that out to my local Grafana Cloud account, and I am only creating this pipeline for logs. Currently, we don't care about metrics and traces. Then I can test it out. Syntax is correct. Let's go next. Now, let's say I'm a user here, and I'm not exactly sure about this configuration. Maybe it's good, maybe it's not. I'd like to test it out first. Well, OK, I have a dev environment, and I have some collectors running there. Let's send it out to them. How can I find them? Let's just search for environment. Look at that. We do have a dev environment, and we have 2 collectors running in our dev environment. Well, that's not enough. I mean, you don't want to send this out to every single one of those. At the end of the day, you want to trim it down further. Maybe some of them only collect metrics. Maybe some of them only collect logs. I created a log pipeline, so let's look for collectors that only pick up logs. Maybe something like this. Collects logs equals to true. Nice, there is one. OK, awesome. So at this point, I'm happy. It's one collector. Let's just roll it out, and let's see what happens. Right? So I'm going to click Save. I'm going to save my pipeline. And by default, we keep it turned off. But to activate it, all I need to do is click one button. Now, what this is going to do is our server is going to send this new configuration to my locally running collector, and I will be able to see those logs if everything works well. Now, I hope some of you are familiar with our logs drill down, but if I go to my logs drill down, look at that. I'm seeing a service here, right? So it's sending out the metrics from the last 10 minutes. It started 13 minutes ago. This is roughly when Bejal started the demo. So it's kind of, OK, so now we've picked up the logs, and we're seeing them in Grafana Cloud. If I set the refresh rate to 5 seconds, we're going to start seeing the logs come in real time. So this is 14 minutes and 10 seconds ago. Wait 5 seconds. We're going to see it 10:15 right there. And so our logs are coming in real time. And what have we done? We didn't have to meddle with local config files. We didn't have to manually restart any collectors. We did it all remotely from fleet management, and it just worked. So our goal for this is now to bring the same first-class experience to Alloy's OTel engine. And stay tuned for that, because we have some really, really exciting stuff coming up there. We can go back to the slides, please.
Great. So I think probably at this point, it's pretty clear that at Grafana, we really want to adopt and embrace OpenTelemetry standards into our products. And for what that looks like for Alloy is making sure that we are meeting this definition of a collector distribution, and that we are providing a native experience to the users that really care about that. For fleet management as a product, we are extending it to not only manage the OTel engine, but also be able to manage any collector distribution. And so the design principles for those both are the same. We want to embrace open standards, and we want to avoid vendor lock-in. So if you're interested in getting your hands dirty with the fleet management experience, you can come find us after and ask for access to the private preview. As I said, the OTel engine is available now, so please do play around with it. Let us know if you have any questions. We'll be around to chat to you. We're really excited about this, and we hope you are as well. Thank you so much for being here, and thank you for listening.
Thank you.